In this video, we're going to talk about adding and subtracting fractions with unlike denominators. If you had 3 over 4 plus 10 over 8, you can reduce this fraction. 2 goes into both of these numbers 4 times and 5 times. So you basically have 3 over 4 plus 5 over 4. The denominators are the same now. In addition, when they're the same, keep it the same and add the numerators. And 4 times 2 gives us 8. So 8 over 4 is 2. Now, let's look at a similar problem to this one. If you have 3/4, which cannot be reduced, and you have 12 over 8. You know, 4 goes into both of these numbers. 2 times and 3 times. But then the denominators are not the same. Instead of doing it that way, what you could do is say, you know what? I can divide these numbers by 2. And that gives me a 4 here and a 6 here. Fair enough. I can divide the 6 over 4 further. But I don't want to. Why? Because now they have the same denominators. And 3 plus 6 is 9. And I'm done. So be a little bit careful when you're reducing. Maybe you're reducing too far. Of course, if this was 3 over 5 plus 12 over 8, there's no way I can get that to be a 5. So then I would divide by 4. Then now I have 3 over 5 plus 3 over 2. And I want to find the first common multiple. But that's easy, because 5 is just 5 to the 1, and 2 is just 2 to the 1 as prime factors. So it's going to be 2 to the 1 times 5 to the 1, or 10. That's going to be the least common multiple. So I want to write 3/5, which are 10 on the bottom. And I also want to write 3 over 2, with a 10 on the bottom. That means I want to change the way these fractions look like. Which means I take 3/5 and I multiply it by 1. Because if I multiply it by other than 1, it will no longer equal 3/5. And if you're going to change the values of the fractions, why don't you change the first fraction to 1, the second fraction to 1, and when you add, you get 2. You'll be wrong, but it was pretty quick to do it that way. You can't change the value of the fractions. You can change the way they look, but you can't change the value. Well, I know one thing, that 5 times 2 gives me 10. And if this fraction has any hope of equaling 1, whatever I have in the bottom, I have to put in the top. 2 over 2 is 1. 3 times 2 is 6. Double check, 5 times 2 is 10. So I get 6 over 10. Now 3 over 2 is equal to itself times 1. Now, so let me write 3 over 2. 3 over 2 is equal to 3 over 2 times 1. 2 times 5 gives me 10. But this has to be 1. Well, if I put 5 in the bottom, I have to put 5 in the top. 3 times 5 is 15. Adding these two fractions on the left is the same as adding these two fractions on the right. The reason is, if you reduce this fraction, you get 3/5. the same number we were supposed to add. That is one of the two numbers we're adding. And if you take 15 over 10 and you divide the top by 5 and the bottom by 5, you get 3 over 2. The second number was supposed to be adding. So again, adding these two numbers is exactly the same as adding the two original numbers. And since those two numbers, these two, have a common denominator, I keep them and I add the numerators. And there is my final answer. Okay, this equals 21 over 10. Let us try another one. Suppose you were to add 3 over 6 to 2/9. Now, 3 and 6, they have a common divisor, 3. That is, this is the same as adding 1/2 and 2/9. And the LCD is 18. Two ways of doing it. You can do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 9, that's not on the list. 18, yep, that's on the other list. Say 18 is the first common denominator. Or you can say that 2 is just 2 to the 1, and 9 is 3 squared. So I see 2's and 3's. The largest power of 2 I see is 1. The largest power of 3 that I see is 2. So you get 2 times 9, 18. A half is equal to itself times 1. 2/9 is equal to itself times 1. And it's going to be a fraction. 2 times 9 gives me 18. So if this fraction has any hope of being 1 and the bottom has to be 9, then the top is 9. 1 times 9 is 9. 9 over 18 is equal to 1/2. 9 times 2 is 18. So I have to have 2 on the top, because 2 over 2 is 1. 2 times 2 on top is 4. 9 times 2 on the bottom is 18. Now I can add these fractions. Adding these two box fractions is the same as adding these two circled ones. And by design, they both have the same denominator. Add the numerators. 9 plus 4 is 13. So what is this equal to? 13 over 18. Or if you prefer, how much is 3 over 6 plus 2 over 9? 13 over 18. What if you have 6 over 2 plus 10 over 5? Well, 6 divided by 2. If you have 6 items and you cut them in half, you get 3. 10 divided by 5 is 2. I know it is, because 5 times 2 equals 10. Well, the answer is 5. Didn't even have to get common denominators. You can argue, though, that we did. I mean, this is 3 over 1 plus 2 over 1, but let's not even go there. If you have 3 over 15 plus 21 over 10. You know, 3 goes into both of these numbers, 1 time and 5 times. So this is the same as 1/5 plus 21 over 10. Well, 5, that's just 5. And 10 is 2 times 5. And these are all to the first. So the LCM, well, I see 2's and 5's. The largest powers I see of 2 is 1, and of 5 also 1. So I get 2 times 5 or 10. So I want to write 1/5 with their 10 on the bottom. And I want to write 21 over 10 with their 21, with their 10 on the bottom. I want to write 21 over 10 with their 10 on the bottom. I hope you realize that it's 21 over 10. 21 over 10 does not equal to 7 over 10. It does not equal to 3 over 10. It does not equal to 17 over 10. It does not equal to 105 over 10. It equals to 21 over 10. Okay, so I want to take the 1/5 and I want it to look differently. That means I want to multiply by 1. The way I'm going to write 1 is not 4 over 4, it's not 7 over 7, it's 5 over 2. Only because 5 times 2 is 10. And 1 times 2 is whatever it is. It's 2. Now, if you insist on writing something here, times 1, do 1 over 1. After all, 10 times 1 is 10. So, adding these two numbers is no different than adding those two numbers. And those two numbers are friendlier to add because they have a common denominator. 2 plus 21 is 23. So 3 over 15 plus 21 over 10 is 23 over 10. Let's try another one. Suppose you have 8/3 and you want to take away 1/6. You can't reduce. Okay, between, 3 is 3. 3 is 3 to the 1. 6 is 2 times 3, all to the 1. So the first common multiple of 3 and 6. Well, the different bases I see are 2 and 3. The largest power of 2 that I see is also the only power of 2 that I see is 1. And between the other powers of 3, which are both 1, 1's the largest. And 2 to the 1 is 2, 3 to the 1 is 3, so it's 6. So I want to write 8 over 3 with the 6 on the bottom, and I want to write 1 over 6 with a 6 on the bottom. Well, this one, I want it to be a no-brainer. It's 1 out of 6. Well, here, if you multiply by 1, that's 2 over 2, you will have changed the way this looks. Because now it's going to look like 8 times 2 over 3 times 2. It's now going to look like that. Why did I put the 1 this way? Because 3 times 2 gave me 6. And remember, this is a subtraction problem. In subtraction, if the denominators are the same, keep them and subtract the numerators. 16 minus 1 is 15. But 3 goes into both of the numbers. 3 goes into the top number, and 3 goes into the bottom numbers. This tells me that the problem we were asked is equal to 5/2. Also, make sure you can't reduce any further. Let us try another problem. Suppose you have 7 over 2, 3, 4, and you want to add 1 over 117. So 2, 3, 4. The first thing I might notice is that those numbers add up to 9. That means 9 goes into that number. But you know what? Before I divide that big number by 9, I'll divide it by 2 first. Oh, I didn't even realize that that's also that. So we can keep the 117 just as 117. The least common multiple of 2, 3, 4, and 117 is simply going to be, well, we have 2 and 117, and the highest powers are 1. So it's 2 times 117, which is 234. So I want to write this with the 234 on the bottom, which is pretty simple because it already has it. And I want to write 1 over 117 with the 234 on the bottom. So I'm going to multiply top and bottom by 2. So now I get 2 over 234. Adding these fractions, these two, is the same as adding these two. And I get 9 over 234. And this multiplies, those digits add up to 9. That means 9 goes into 234. Twice, that's 18. 5, bring down the 4, goes in 26 times. So this is 9 over 9 times 26. It reduces to 1 over 26. That completes the video on adding fractions with different denominators.